Good afternoon, everyone, and welcome back to another powerful chapter in Machining Harmony series, powered by Pramet and Mastercam India. Today, we step into a domain where efficiency meets intelligence, where precision meets versatility, and where machining operations converge into seamless symphony, conquering multitasking machining, productivity in one step up. Multitasking machining is no longer just a trend. It's a strategic enabler, a productivity catalyst, and a game changer for manufacturers aiming to dominate speed, accuracy, and flexibility. Thank you for joining us. Your curiosity and commitment to advancement are what keeps us moving. Before we go ahead, some safety reminders. Before we dive into few essential reminders, whether you're joining from shop floor, office cabins, or home workspace, please stay mindful of your local safety procedures. We are taking this call from our office and we are very well aware of our safety protocols. Whether this session is fully secure, so every link shared in this session is verified and safe. And most importantly, this is a psychologically safe environment. Please feel free to ask, share, and engage. Few housekeeping rules. All participants will remain muted for optimum clarity. Use the Q&A panel anytime your question fuel this session. We'll address as many queries as possible during Q&A. This session is recorded. You will receive the recordings and materials shortly. If you encounter any glitch, a quick log out and then logging in usually resolves the problem. Now moving on to agenda. To set the strategic tone for today's discussion, it's my honor to welcome two key leaders that continuously steer innovation with clarity and vision. That is Mr. Sharat Kulkarni, Managing Director India and Sales Director Asia Pramet, Mr. Vineet Seth, Managing Director Mastercam India. Over to you, Sharad and Vineet.
Okay, then good afternoon, everyone. I think it's a great pleasure to be participating in this machining harmony series, which is, I guess, it's become very very popular. Well, I think thank you very much for attending and thank you for your time. And what I'd like to start with is saying that we received very good news on the when it comes to the Indian GDP. If you're caught up with the news, the Indian GDP grew by more than 8.2%, with the growth being led by the manufacturing sector, which was 9.2%. This was a very good news for all of us, and I think this indicates it's a great movement or a one good step ahead when it comes to the growth of the manufacturing sector in Asia, in India. And this growth has been, of course, been driven by the government and its Make in India push. Also, things like PLI, our quest for implementing the Industry 4.0 and increased digitalization of the manufacturing industry are some of the drivers which are enabling this growth. As India moves from being a kind of a low-cost, high-volume producer, to more precision-led and tech-led, kind of a situation. I think this journey, I think, is going to be very interesting for us, because we cannot no longer be just dependent on the domestic consumption story. We have to export. We have to become a part of the export chain. Increasingly, even more than what we have done in the past. And therefore, we see also the rise of some of the new sectors now. I think, in the Indian manufacturing industry, like semiconductors is a very recent addition. But then we are seeing increasingly sectors like, aerospace now, I think, and also we can see, medical, which are, I think, really in that sense, very high-tech manufacturing. And in all these things, a very important thing, which is machining is important part of this manufacturing story. And when it comes to machining, multi-axis machining is, of course, I think something which is leading the tech side of things. Uh, Multi-axis machining, in combination with um, players like Pramet and Mastercam, we bring to you to the latest in this area, and we offer our our perspectives, our learnings, and we hope, I think, that you could benefit out of it. Multi-axis machining in general offers much more freedom than traditional three-axis machining. It enables you to enter the components from different perspectives, different angles, and thus offers much better flexibility in machining. When it comes to the reducing the human errors, of course, multi-axis machining is much better because it reduces the multiple setups, for example. At the same time, I think when it comes to the cutting tools in combination with software like Mastercam, it enables you to have much better surface finish, accuracy. Yeah, I mean, and these are some of the key advantages. So what we, what we see with the multi-axis machining. And then, of course, in our experience, it leads to a much better optimized cutting tool parameters, and which means that the toolware is controlled, your productivity is increased, uh, and so it leads to overall benefits. So in this series, of course, we will talk more about that, and we will try and present a picture of how it will benefit you, especially if you are in sectors like aerospace and medical and even in automotive. I think this is something which is indispensable for you today. So thank you very much for attending this webinar. And then I would like Vinit to say a few words on this. Vinit, over to you, please.
Good afternoon, everyone, and thank you, Sharad. Brilliant introduction. And certainly it has really caught on. The Harmony series with Dormer and Mastercam certainly has caught on. I see people going to it, watching it, asking about it. So interesting, and thank you for allowing us to be a partner here in this initiative. So once again, a good afternoon to everyone who is attending this. Um, the India growth story, as Sharad mentioned, with the recent GDP numbers and the growth that we are seeing across sectors, is certainly a great thing that is happening in our country right now. Our dependence on only the domestic consumption is there as a backbone, but it is also being firmed up by our exports. So the landscape is changing quite rapidly and at a pace that we haven't witnessed before. And whether we look at the automotive, the aerospace, the medical, general engineering, energy consumption, energy side of things, there's a very clear shift that is happening. The customers want shorter lead times, they want tighter tolerances, and they want very predictable quality. And for the Indian shops, whether they be small, medium, or large, the question no longer is, can we machine this part, but how efficiently can we manufacture it or machine it? And one of the biggest constraints that our industry faces today is space. Real estate is very expensive, and the costs of real estate are rising quite rapidly in both cities and industrial corridors that we have. Uh, every square foot on our shop floor has to justify its presence. This means the traditional model of machining or using multiple machines, one for roughing, one for finishing, another for milling, along with multiple setups and multiple operations and operators, is becoming increasingly unsustainable. It slows down the production, increases work in progress, and introduces variation, multiple setups, of course. And this is where I think multitasking machines and the economy of a single operator managing more work becomes extremely powerful. A mill turn or a multitasking platform lets you complete more operations in a single clamping, often in a single cycle. The benefits are immediate. There is less handling. There is a lesser queue time. There are fewer errors and a dramatically smaller footprint per part produced. In other words, a far higher return on investment per square foot of real estate, which itself is a big game changer. But hardware alone is not enough. The real advantage actually comes when advanced tools and advanced software work together in harmony, of course. Modern cutting tools like those from Dormer Pramet, combined with intelligent CAM software like Mastercam, give manufacturers a level of predictability and repeatability that was difficult to achieve earlier. Optimized tool paths, proper tool management, vibration control, and digital verification, I think, bring down the risk while pushing the productivity higher up. And as users, when you adopt the right technology, programming time goes down, cycle times drop, tool life improves, and quality becomes more assured, batch after batch after batch. More importantly, skilled operators can now oversee more complex jobs with confidence because simulation, synchronization, and process planning are handled digitally before even the first cut is made. We, as India, when we aim to become a global manufacturing hub, these capabilities are not optional; they are essential. The shops that embrace multitasking technologies and smart manufacturing practices will be the ones who lead because they are the ones who are able to produce more with better quality, in less space, and with fewer interruptions and better parts. I hope you will benefit from the experiences shared by our expert speakers going forward today. And I welcome you all again to this series of ongoing presentations by our experts. We are companies not just with great products, but we are backed with great people. And we can assure you that together, the kind of level of support that you can expect from both these teams would be unparalleled in your journey towards improving your manufacturing setups and processes. Thank you very much.
Thank you, Mr. Vineet and Mr. Sharad, for your sharp insights and direction. Next, we hear from two leaders who ignite our collaborative momentum, driving performance and market acceleration. Mr. Amit Raina, Vice President, India Sales, Pramet; Mr. Daniel Raravi, Director, Marketing and Strategic Initiatives, Mastercam India. Over to you, Daniel and Amit.
Yeah, hi. Good afternoon, everybody. So, like what Sharad and Vineet already told, India is today the bright spot in the whole global economy. I think so. We are growing very fast, and it also gives us an opportunity that how do we become more efficient? And I think so. What's the best way to combine best cutting tools and best CAM softwares, which are intelligent and which can help you become more and more productive and efficient? Because as the growth goes, sometimes to manage growth in the right time, where you cannot invest in capital equipments very fast, but you can improve your productivity so that you are able to take the bigger slice of the growth is even more important. So with that, I wish you a very good session here. I think with intelligent cam like Mastercam and with good cutting tools, I'm very sure you can improve your productivity even without investing in capital at this right time when we have growth at our doorsteps and we can take the best slice out of it. Thank you. Over to you, Danny.
Thank you, Amit. Good afternoon, everyone, and welcome to the third in series of tools and software in concert with Dormer, Pramet, and Mastercam. Across all my interactions with manufacturers, whether they're spread across the country, the narrative has been remarkably similar. Customers continue to want shorter development cycles. They want higher repeatability. They want an assurance that each batch that they produce looks as good as the last or as accurate as the last at the very least. And we as leading organizations in technology cannot respond to the requirements of the 21st century with tools or workflows from the 20th century. I think that's the foundation of what we are about to present today. And like all of the leaders, Mr. Sharad and Mr. Vineet said that, India has reached an inflection point in manufacturing. So we have moved beyond the phase of proving competence. There was a point where we used to prove competence, but I think we have crossed that point. We can machine complex parts. We can meet tolerance. This is no longer the question. The real question going forward is, can we deliver this capability at scale, sustainably, and in a footprint that is cost justified in timelines that the global market expects? Right, and this is where the multi-machine, multi-setup model, shows its lacunae, and the leaders before me have covered this amply. So for Indian manufacturers, this alignment of machine tools, the new age tools and new age digital workflows is not a luxury, it's a critical capability now. And as global supply chains diversify, What we need to do is take on more technically demanding work. Um, we adopt to these modern and integrated machining strategies that will lead the way for the future and will deliver consistency at pace that the market demands and not at what people are used to. And they will do it with far more efficiency as far as deployment of people, space, and capital is concerned. So the opportunity is very significant, and with the right mindset and right technology stack, we are all well positioned not just to participate in this growth, but also to shape it. And I'm sure my colleagues, will amply add on to these points, in a sense, on the technical front, as I hand it over to Mr. Sandeep Pandey and Mr. Sitanshu Mohanty. Thank you very much all for joining us.
Thank you, Mr. Amit and Mr. Daniel, for laying a powerful foundation for today's deep dive. And now, the heart of today's session. Multitasking machining is the ultimate productivity multiplier. It merges operations, eliminates idle time, streamlines complexity, and delivers unmatched machining efficiency. Guiding us through this high performance landscapes are two experts who epitomize technical mastery. Mr. Sandeep Pandey, Product and Application Manager, Dom Pramet, Mr. Sitanshu Mohanty, Technical Director, Mastercam India. Over to you, Sandeep and Sitanshu.
Yeah, thank you, Priyanka. So I'm Sandeep, Product and Application Manager, India, and I welcome you all for this Machining Harmony concert series. So many of you remember our previous session on high speed machining and this multi-axis machining, which we conducted in the month of July and in September. So myself and Sitansu had the privilege to present over approximately 150, more than 150 participants. And the engagement and the feedback what we received from the participants was really motivating, and it gives us the sense that we continue these sessions in future also. So in line to that, now we are presenting this session for you guys, where we'll be talking about the multitasking machining. So over to you, Sitansu.
Yeah, good afternoon, everyone. Thank you for joining. And thank you, Sandeep. It's a good start. So, as you can see, the topic, it's a multitasking, and it's a third series. Initial series, we have started with turning, dynamic milling. Then we have gone to the high-speed machining as well as the 5-axis. This series, we are talking about the multitasking machines. If you go to the next slides, let's see the pictures, the images. After seeing these images, what exactly you are able to understand that those parts require a multitasking machines. Think if this part or this multitasking machine is not available today's world, so how we are going to machine those parts? Previously, people are also machining, but the thing is, without Milton, without multitasking machines, they have to make a turning profile. They have to make a multiple setups for the milling. So as we discussed in the previous sessions, not previous session, this sessions, some space, because if you have to put a multiple machines for the turning one machine, roughing one machine, finishing one machine, there is a space is constraint. So to avoid those situations as well as the accuracy finishing, that also comes into the picture. So the system has been evolved, the machining has been evolved for the multitasking machine. When you discuss about this Milton module, this is a combination of milling and the turning strategies. All it support all kind of a strategies, options and everything. Additional to that, it support the part holding, bar stock, part transfer, holding the parts between the main spindle and sub spindle as well as the transfer. It supports everything. Let's understand what is multitasking, how it will help you. Go to the next slides, please. Yeah, when you see, what is multitasking machine? Multitasking machine is we'll say it's a machine which can operate many operations, many thing in one setup. This is what we are exactly looking for. Once the part is loaded with the automated part, with the bar stock has been loaded into the machine, it has to do the turning applications, it has to do the machining application, it has to do the multi-axis applications, as well as the both sides setups has to be reduced. So the capabilities, it's reduced the cycle time, it's increased the accuracy because the setup time has been set to one setup. It is not a multiple setups. We call it as a multitasking because it's reducing the setup and reducing the machining time, and it's increased the productivity. And which type of customers will require this kind of a machine? That is also a big question. Normal die mold industry does not require such kind of a multitasking machine. But today's we are more focusing on the aerospace, some part of automotive and the medical. These are the major industries where we are able to run such machining because the parts are complex, process are complex, and people have to think differently to minimize the process as well as the cycle time. And this is the multitasking machine will help you in this. When you're what are the modern challenges when you see all those images, it looks little bit of complex images, but if you go for a specific strategy, specific method, specific tools, and it will try to make the complex process into a simple process. You have to divide it the process into a different steps and different stages. Like first I'll do the turning and make a specific tool paths with specific tools, customization tools. Then you go for a multi-axis machining with a B-axis machining because this multitasking machine supports many axes that we're going to see in the further slides. Selection of strategies and most importantly, the selection of tools. Sandeep, you can suggest some tools on this. So how tool selections, and one thing I just add here before Sandeep take it further. So tool selection is important because we as a library, we understand Dormer Permit library into our system. Means we can download all the 3D models, tools into our library to incorporate to create the tool paths.
Yeah, so
Yes,
rightly,
Sandeep.
yes, thank you, Sudhanshu. So as you mentioned rightly, so basically turn wheel machines or the maybe we can call it multitasking machines. It can combines various operations like milling, drilling, tapping, turning, and even sometimes the grinding also, or maybe to cut the gear cuttings in a single setup. So while they are offering such kind of high flexibility and productivity, so it comes with a lot of complexity also. So you can see in the image where a spindle is also a vertical spindle is there at the same time. Turret is also coming into the picture and doing turning operation. So talking about the what is critical in this when we are selecting the tools for these kind of multitasking machining. So before we select the tool, we need to understand the work holding and the fixture complexity. Because we have to do the lot of operation in a single setup, so we don't get much space to clamp the jobs or maybe to clamp the your part. Also, when we are doing this milling operation in this multitasking machining, so the dynamic stability also it comes into the picture because in milling there's like the cutting forces will be lot of radial cutting forces will be there, and which can distort your part or maybe which can deflect your parts, maybe the stability, or maybe you can see the parts clamping. So talking about this, so means like coming to this maybe, so while selecting the tool we should be going with the tool which have right geometry, which can generate a which will generate a lesser cutting forces, so that your part will not distort. And also when we are going for this multitasking machining, so basically many of the times one tool will be doing multiple operations, and what happens, sometimes one tool will be running for a very long duration compared to in a normal turning or in a normal maybe machining centers. So what happens, your tool needs to have such kind of geometry, such kind of substrate, such kind of coatings, so that your tool lost your tool can run for a longer tool life, and so that you need not to worry about like the your part rejection or other things. Because if you will not able to identify, or if your tool gets wear very soon and unfortunately you could not detect the wear timely, so it can lead to the rejection of your part, or it can lead to the bad surface finish of your part. So all these things can come if you will not select the right tools. Yes, Sitan, so what's your input
Yeah.
on this?
Yeah, absolutely. The selections, tool wear, all those factors related to the finishing as well as the dimensional accuracy. That is very important. You select the right tool. The right tool has been understand by the CAM strategy. That is also important because the tool which you have selected is a standard tool as well as the customization tool. That tool has to understand by the software. And the key point is when the toolpath has been generated, that has to be error free. Machine has to run and without any errors, without any collisions, everything can be optimized within the strategy and combination of smart tools as well as the smart software that can be combined together. Let's understand what is multitasking machines, how it looks like, what are the things. Next slides, please. So if you see this particular machine, you can see there is XYZ is a common standard 3-axis machines. But when you go for a multitasking X, Y, Z, B, C, when you include the head orientations, main spindle, sub spindle, turrets, because multitasking is always more than 9 axis. So uh, all the operation, like Sandeep was explaining in the previous picture, one tool is doing drilling operation, other is doing some turning operation, some other tool is doing the 5-axis machining. So multiple tools, because we have a multiple turrets, upper turret, lower turrets. So those operation combined, synchronously it is combined, and it shows, say, within a limited time, within a shortest time, how to reduce the cycle time. It has been reduced cycle time because the synchronization of the many parts. And when you incorporate more axis, the important is the collision chances, the collision between the axis, collision between the part and fixtures, everything a user need to consider. For that reason, within the software also, we incorporate 2, 3 things importantly. First is the complete machine model setup has been incorporated inside the tool. The tool geometry, as we discussed, 3D tools or any profile, any customizers tools has to be incorporated within the software and the strategies. These 3 things has to be combined together to create a nice tool paths which can be collision free, error free, and the user will get more confidence on that. This turn will always allow the complex profile to be machined in one setup because we have all axes incorporated together. Also, if you go to the next slides, we can able to see there is a many turrets and you can assign specific slots for the specific tools. Like I told you, we can directly import the Dormer Pramet whole library, whole models library into Mastercam, and we can assign number of tools, number of holders, everything, whatever the library they have, we can directly, Sandeep, we can import inside the software and I can able to create the strategies. So can you just throw some light on this kind of a tools and how insert will help you in this?
Yes, yes. So, you know that many of these machines comes with multi-station half index tool locators, telestocks, steady rates, collet chucks, then the VMC spindles, or maybe the which will be having the HSK or BT tapers. So you will see there's a multiple combinations of you will see a different kind of work holding tool holding arrangements. And fortunately in Dharma Pyramid, so we are equipped with all kind of these kind of tool holdings arrangements where you will find we have the PSC or maybe the Capto systems. We have the simple turning tool adapters. We have the VDI adapters. We have all kind of spindle tapers, BT, BBT, HSKs. So we have everything. And as you rightly mentioned, Sitansu, so we have the models available in our in the Mastercam library, as well as it is available in our website where it's free for all. Anybody can download the 3D models and they can use it for the simulation purpose. They can easily incorporate in their software and they can use it for the simulation purpose.
Absolutely.
Yeah.
Next slide.
Drew, next slide, please. Yeah. As we discussed about the multitasking setups. So now again, let's discuss more about the role of cutting tool in multitasking machining. So you know that in multitasking machines, maybe we can say the turn mill or mill turn machines, the cutting tools are really very critical in enabling these multiple machining operations in a single setup. Because in these machines, combining turning, milling, drilling, and other processes, the cutting tool system should support the high flexibility, stability, accuracy. At the same time, it should be giving the more productivity also. And why it becomes really very important, because you need to I mentioned earlier also, you need to manage the cutting forces, different cutting forces. The cutting forces will shift in between the radial forces during the milling, the axial forces during the drilling, the tangential forces in turning. And your tool should compensate all these kind of the cutting forces, so that it doesn't go to your part and it doesn't go to your spindle. It should avoid all these kind of vibrations. And also, it at the same time, it should be maintaining the stability. When you are selecting the tools for this multitasking machining, you should always keep the tool overhang very optimum, because even 10 of overhang can destroy the performance of the tool. So it is very important that you keep a very optimum tool length. And I think here the Mastercam comes into the picture, where you can select a very optimum tool length, and you can see the simulation, so that you will not face any collision issues in while running the actual program. And as I mentioned, and this reducing the tool overhang and keeping the correct geometry, it will increase the productivity of your tool. And by doing all these optimizations, selecting the right tools, right geometry, right coatings, right substrate, the correct chip breaker design depending on your workpiece material, if you are machining the enconal, titanium, or maybe super alloys, steel, or non-ferrous, whatever it is. So depending on that, you need to select the right geometry. Also, one more important thing is, the like when you are doing this multitasking machining, so you will not have a very good space for the chips evacuation. So your tool should be capable enough to break the chips, so that your chips can come out very easily. And also, it should be equipped with the through coolant features, so that you should not be getting the chips accumulation issue in the setups, which can further lead to the bad surface finish, or maybe it can scratch your components. So by doing this, you can selecting the right tools, keeping the right tool design, you can increase your productivity. You can utilize the your setup in a very well manner. You can do multiple operations. Also, you can run your machine for a longer life, because if your spindle will not get harmed, and you will maintain the right spindle power and torque, so your spindle your tool life, your machine life will be longer. So
I absolutely agree
yeah.
with Sandeep. The important factor for a programmer is tool geometry, as you mentioned, tool chip breaker, which needs to be break the chip in continuous fashion, so chips will come out from the machine, as well as the overall length. These are the major three factor we take into the while a programmer creates any program for the multitasking machines. So in multitasking machine, correct geometry. Dhruv, we can go to the next slides, please. So while generating any programs, it's important, as you Sandeep said, is geometry, because that particular geometry it prevents the collisions, improve the toolpath, because the edge point, the cutting edge point, cutting edge profiles, the everything improve the toolpath accuracy, and the it's find out is there any additional cut or additional hitting on the fixture, hitting on the part workpiece, everything will calculate it to that particular geometry, as well as cutting parameter. As we mentioned, we can directly incorporate the Pramet tool library into Mastercam. So automatically all those parameter also included. That is the thank you Sandeep for giving all those parameters also. If a new
Yes,
programmer
yes,
can
yes.
easily sit and understand when I'm browsing this particular tool, the efficient parameters is already I'm getting it from the tool manufacturer, as well as Mastercam has a capability when you're machining same tool with a different material also, Mastercam also suggests some kind of a parameter which will help the programmer as well to generate or create a programs for easy way. That is the major process is the things, the tools which are available with us should make everything more smoothly and easily. Like we discuss about the machine models, like why this simulation and digital twin simulation is required, because this machines, as it's a multitasking, we have a many axes moving together, multiple operations going, two operations going on the sub spindle, some operations going at the same time, some operation going on the main spindle. So it's a combination of many things to avoid and optimize cycle time, to optimize the exact cycle time. But at the same time, users should understand whatever the passes I have generated, that should run correctly on the machines. So that's give the confidence that, as Sandeep told, the tool overall height is a matter. How you are getting a finish, whether that height create a problem for other tools. When other tool working, is this tool will collide with spindle. So all those things you can easily see it on the screen before going into the actual machining. That makes the user more confidence. But when you are confident, you get a right tool, right strategy, right passes, and you can simulate everything on your screen before going to the machine. That gives you more confidence how easily and quickly this can be possible. Let's go to the next slides. I'll explain you how software allow you to generate such toolpaths for those kind of operations. When you open a Mastercam, we can able to see we have a different module for the different industries. Like we have a turning module, we have a milling module, and today we are discussing about the mill turn, the multitasking machines. When you are going for a mill turn or multitasking machine, the initially you have to define which machines you are going to use it. You can see it on the screen. You can specify the machine name, whether it's a Mazak, whether it's a Haas machines, whether DMG machines, or any kind of machines that you can directly select in within the software that I want to machine the part on this particular machines. When you go to the machine side, the next slides, please. Then you have to define what kind of a part you want to machine, like the 3D model, which I'm going to, like I have shown you in the images in the initial slides. These are the parts, part geometry. You have to just select the part geometry, and you have to select the stock. What is the material? Either you are looking for a rectangular material or a circular material, you have to define that stock as well. So just minimum setups, like if you go to the next slide also, you can able to see these are the minimum setups, how much hold out for the job, how much you are going to clamp it. So minimum information the software has to be user friendly. It has to give you minimum things to which is required to generate any kind of a passes. Like you define the machine first, define the part geometry, define the stock, define the holdout system of the machine. Next slides, we can able to see different type of tools. As we discuss about the library, you can directly import. When you define, I am going with the upper turret. So that which are the suitable tools are available for the upper turret, it will show you that only. It will not show you the whole assembly. That is important, because if you get 100 tools, you'll get confused. But your turret can capability of 16 tools. So it will show you all the 16 tool available on 1 to 16. So that makes you process easier. That is important. When you using a tool, you have to make the process easy. If it is difficult, then the user will try to make a mistakes. To avoid the such thing, avoid to mistakes, we use the advanced options. This is called the advanced options. This help you to selections proper tool. Go to the next slides, please. So then you just define some lead in, lead out, because that is also important part of programming. How your tool is going to enter into the material. If I directly plunge into the material without any strategies, so it may break the tools. It may break the spindle. It may give more load on the spindle. It may throw out the job. So this options software automatically allow you to go through all those options. Just you have to tick, untick, or tick. So automatically it will create those strategies. Next page, please. Yeah, along with that, as I told you, we are importing the complete machine within the software. inside that also we can define the steady rest or the center subspindle rest. All the fixtures are available on your complete component. When you're machining the component, there may be a fixtures, there may be a steady rest, which are going to hold your part or hold your job. So that's allow you to check the collisions, because as I told you before, most important is uh, correct tool selections, strategies, and finally you have to run on the machine without any collisions. So that gives you, you are incorporating everything in a single window.
Yes, it also, I think it will be nice if we can play some video and demonstrate some real life example, and then we can talk about it, talk little more about the tools and like how
Ab-
this works.
Absolutely, absolutely. If I go to the next slide, I can able to show you some videos.
Yes.
Just you see that particular part. This is the machine we are using is DMG Morisaki NT4300. Okay. The part model is called as a Ironman powerhouse unit housing. So you can see this particular, the part has been first placed in the subspindle and it's doing their operations. At the same time, it will change the operations from the subspindle to the main spindle, and it will start doing that operations. This kind of a synchronization is very important to avoid any collisions, anything. You can see in the turret also, Sandeep, you can see all those turrets, how much tool length is required. If tool length is larger size, whether it is colliding with the other part of the machines, those
Right.
things also you are able to see it. Here you can see there is a long range of tool has been used over here. So I think Sandeep, you have some solution. I heard somewhere Dormer Pramet has a solution for this longer tool length.
Yes, yes, yes.
So can you show about that tool length as well?
Yeah, yeah. Maybe in the next slide, Drew, can you go to the next slide? Yeah, so when we talk about the longer drills or maybe so Dormer Pramet is, as I mentioned earlier also, so Dormer Pramet is equipped to deliver you the solutions, entire solutions for these kind of multitasking setups. So out of all these solutions, we have one solution which we call modular drills. So modular drills, it has a multiple features compared to the normal indexable drills. So when we talk about the indexable drills, so we don't get a high quality holes from the indexable drills, but with the help of modular drills, where there will be a separate head which will be of solid carbide, and then there will be a drill body which have a length of up to L by D 12, and the diameter range starting from 12.5 up to 42.5. So you have a range, very wide range also, where you can go from diameter 12.5 to 42.5. And the L by D ratio starts from 1.5, it goes to L by D 5, L by D 3, L by D 5, L by D 8, and L by D 12. The beauty of this product is many of the other cutting tool suppliers also have these kind of similar products, I would say. But the beauty of this product is the easy exchangeable heads. So what happens when you are doing this multitasking machining? So taking out the tool from the machine and putting it again into the spindle, it takes a lot of time. But with this tool, what makes it very easy, that there are two mounting screws are given into the head of the drill head, which you can easily replace, just keeping your tool into the holding system or into the machine itself. You don't need to take out the tool and go to the Zoller and again just changing the entire tool and again putting it to the spindle and again going to the, so it takes a lot of time. So by just putting this tool into the spindle, you can reduce your lot of man hours, which will further increase your productivity. At the same time, you can see there is a serration in the head at the same time, and also the serration at the drill body. So it gives a very strong rigidity of your tool, and so that your tool can go on a higher cutting parameter without deflection, and it can produce a very good quality tool, very good quality holes also. Also, the product comes with all the drill bodies are equipped with the through coolant features. As we mentioned, this multitasking requires these through coolant features so that we can avoid the chips accumulation issues. Also, the heads are suitable for workpiece material group like steel, stainless steel, cast iron, and also super alloys. So all these things combining, it gives a very good productivity benefit when we are talking for such kind of multitasking setups. We can reduce lot of time, we can get a good quality hole, we can increase your cutting parameters. So these drills also like if you are doing some solid carbide drill of maybe 14, 15, 16, or maybe about 12, I would say. And so what you need to do, every time you need to take out your tool after completion of tool life, and you need to give it for regrinding. And also after regrinding,
that is important, because this changing of
yes,
inserts is give the flexibility. Regrading always the dimensional issues, cheap evacuations issues, many things comes into the picture. But really
exactly.
nice to know that insert you can change it and reuse the same drill base for the next applications, as well as this through coolant. Definitely this will force the inserts, force the not inserts, the chips to come out immediately from the deeper cavities, deeper areas.
Right.
Great to know
So
that,
what
Sandeep.
so what happened basically? So every time you will be getting every time you will be getting the tool performance as equal as the new one. In regrinding, you will not be getting the similar performance like the new one. So this is the beauty of this product. So which is as equal as solid carbide, but also reduce your cost, giving you the more productivity benefits. So it is a must have tools for your multitasking setups. Uh, to the next slide, Dhruv. Yeah. So addition to that, this we are talking about a good quality tool. The tool should have a longer durability. Tool should be running on a high cutting parameters. So in this series, we have a new fourth generation multi CVD turning grade, which we call it T9415, which have the multiple features. I would say the inserts come with the four coating layers, the adhesive tin layer, then the abrasion resistance GICN layer, then the Al2O3 Alcrona oxide abrasive heat resistant layer, and then after that we have a additional TIN layer, which gives the benefit that the your insert will not be entirely black color. The flank area will be of yellow color, so that you can easily detect your wear. Because again, in multitasking machining, generally what happens, if you have a black color insert, you'll not be able to identify the wear very easily. So that's why we have kept this flank of yellow color, so that you can detect the wear very easily and you can change the tool on time. Otherwise, if you will not change the tool on time, then again this all the problem, you will lose your accuracy, you will lose the part quality, you will lose the productivity, and if in between your tools gets break, you will maybe it can lead to the part rejection as well. So generally in normal CVD coated inserts, the coating thickness will be of around 15 to 16 micron, but this insert has a coating thickness of 22 microns. So again, this gives the advantage of going this insert this grades to on a higher cutting parameter. This gives the advantage of more wear resistance and more heat resistance also. Over to the next slide, Dhruv. So I'm just giving you the overview. Look how the insert looks like. You can see the flank area of the insert is of yellow color. The other part of the insert is of black color. Also, one more additional feature of this insert, that we are talking about the stability, we are talking about the durability, part accuracy, everything. So most of the pressed insert comes with there will be no grinding at the seating area. But this particular inserts comes with an additional advantage, that all the inserts have the advantage of that the grounded seating area. You can see the silver kind of portion, which is the grounded one. Though it is a pressed insert, but still this insert have this feature that the seating area will be the grounded one. And what advantage you'll be getting with this, that whenever we'll be putting the insert into the pockets of the tool holder, so we will be getting a very proper sitting, and your insert will not deflect during the machining, or maybe while taking the higher cutting parameters, and it will give the more productivity. It will give the avoid the vibrations, and it will give a good quality surface finish as well. Over to the next slide,
Absolutely.
Dhruv. Yeah, yes, Siddharth.
Absolutely.
So,
The input for my these are the inputs I thought for the programmers. As you said, there is a 30% thicker in the surface coating. I think this will give you the more cycle time. More cycle time means more running time compared to the other inserts, and surface finish, as well as programmer can use high feed. Where is the today's demand is to reduce the cycle time. When you are going for this multitasking machine, his main concern is the accuracy and the cycle time. So I hope this kind of a technology you are providing does definitely help the user to reduce the cycle time drastically.
right, Stansu. And also, we are talking about the quality, accuracy, and everything. But I think we are missing one part. This is the economy, or maybe the CPC of the part. So here comes this tool, the SW104, which is a triangular insert. The triangular negative insert means double-sided inserts, comes with a 6 cutting edge design, and starting from diameter 16. So again, so like many of the you will be surprised that not many of the competitor have uh, a 6 cutting edge insert in such a lower diameter, like the diameter like 16, 20, or 25. And maybe when we have these kind of setups, so you will be getting a lot of operation which where we need this kind of tool, the smaller diameter tools, which can perform the multiple operations like slotting, or maybe the wall finish. All these things is needed. So here this tool comes into the picture, where you can get the advantage of 6 cutting edge in a diameter 16. Also, this insert have a unique feature of a wiping facet in the cutting edge, which can which what we can do, which can give you the better surface finish while doing the wall finish. So all these features makes this product very unique. And you can when you are by using these tools, you can avoid you can reduce your cost per part. At the same time, you can increase your productivity as well. Over to the next slide, Dhruv.
Absolutely. Yeah,
Yes.
absolutely. By this coating surface, that's wear resistance is increased. That is important because when we have no need to change the insert very frequently. Let's go to the this videos. You can run these videos, please. Yeah, this is a Akuma machine with a Multus U series. Okay, you can see this particular part. It's a this part is called as a space shuttle capsule. So this is same Okuma machines. We can able to do a combination of turning applications, milling applications. You can see this particular machine also has a B axis where you can able to do this. B axis is the head operation, which is currently on the screen. You can able to see it. It's a B AC axis combination where you can use the multi-axis options as well as the turn mill features. This will give a what you can say. It's a give a combinations always reduce your cycle time and the accuracy. That's what we are going to discuss. And in this particular case, you can see there is a dynamic milling also you have been used. 3-axis dynamic milling has been used in this particular module, where it can directly enter into the material and remove the bulk material from the part.
I would like to pitch in here, Stansu.
So I
So you
see,
see this
yes.
dynamic milling strategy, which we had discussed in our first session, and I'm
Uh,
very happy to again say that the Dharma Pramet is equipped with these dynamic milling tools. We have a dedicated end mill series for these dynamic milling strategies.
great. Here also you can able to see the B-axis machining in
Yes.
a closer look. So some profile, 3D profile, 3D not 3D, the conventional 5-axis profiles that can be machined with the ball tool, and it can be easily by tilting the head in a different angles, which some machines, some 5-axis machine also it may not be possible because the reachability issues. With the help of this turning and milling combination, we could able to manage those surfaces machining as well.
Right, Siddhansu. So I think I maybe Dormer Pramet here can help the customers in achieving the good quality surface, as well as they can reduce the cycle time by keeping their CPC by keeping their CPC very low. So Dhruv, can you go to the
Absolutely.
next slide? So here the tools comes in picture, which we call SAT07. The insert is ADEX07. So this it looks a very simple tool, but the it have a very unique features. I would say that no one else is having this kind of unique feature. So I'm just telling here. So this is a tool which have a high feed geometry starting from diameter 10. So in industry, nobody is having a high feed cutter starting from diameter 10. So this is something really phenomenal. So you can see the inserts is having all the capabilities. You can do the maybe the slotting, ramping, helical interpolation. You can enlarge the hole. You can plunge the hole. You can do the profiling. You can do all the things, whatever you need. And that the best thing is like this comes with a again it comes with a different design. It comes with a modular design. It comes with a shell mill design. So like if you need a longer approach, so many of the times when we are doing this multitasking, so we need to go in a deeper cavities, and such a smaller diameter like diameter 10 and diameter 12 for solid carbide, it really becomes very difficult, because if you are using a solid carbide tool and the approach angle is so high, so you will not be able to take the higher cutting parameter. And also there is a chance that your tool can get break. So and after if you use these kind of tools, so you will avoid the issue of breakage first thing, and at the same time you will be able to run these tools on a higher cutting parameter compared to a solid carbide mill because of this high feed geometry. Can you go to the next slide, Dhruv? So you can see this geometry. This is a high feed geometry what we have for this insert, the ADEX07, where you can go with the feed rate of approximately in between a range of 0.25 to 0.9 for a steel kind of material per tooth. So 0.25 to zero point 0.9, which is really extremely good. So if you are using a solid carbide, maybe end mill, so you will not be able to go such on with such kind of high cutting parameters. And you see, so when we are using this high feed geometry, so this high feed geometry, it gives it reduces the approach angle, so that the approach by doing this, so we get the benefit of making this tool as a high feed concept. Generally these inserts come with a true 90-degree design, but this high feed design, the incorporated radius in these inserts make this cutter work as a high feed. And also these inserts have multiple grades, multiple geometries, which can go for maybe other operations, maybe like machining for steel, stainless steel, even for cast iron and super alloys as well. To the next slide, Dhruv. So uh, I said about the indexable tool, but it doesn't mean that the Dormer Pramet is not having the solid carbide range. So we have a huge variety of the solid carbide end mills, starting from flute 1 to up to the 6 to 8 flute, suitable for different kind of machining strategies, different kind of machining operations. For example, the single flute design, the single flute end mill suitable for non-ferrous workpiece of material. And again, I would say this single flute and mill is something which is not everybody is having in their basket. And because of this high core diameter and the larger flute space, you can go this is a carbide and mill, but you can use a cutting speed of approximately 500 to 600 for aluminum machining, which is extremely high, and you can take a feed rate of around 0.3 to zero point 0.4 for these kind of, because of the good chips evacuation space. So your chips can easily evacuate from the machining area, and you can go even a depth of cut of up to 2D also in these cases. uh, I just wanted to show you the glimpse of the Dormer Pramet end mill range to you guys, so that
Yeah, Sandeep, really, really happy to see all those flutes because in dynamic we always machine with the flutes, not with the
Yes.
base. So when the flute increases, the efficiency of tool definitely it will increase and it will give you the more chips outcome, and we can give a larger depth of cut because it is completely machining from the flutes. As well as we have some specific strategies for the finishing as well, like swarf machining. When you go for a aerospace impeller machining, you have to machine with the flutes only. So in those
Yes.
cases, I definitely see this 5 flute, 6 flute, 8 flutes will help us to achieve our machining parameter and the finishing as we expected. It's
So
great to know
Siddharth,
that.
yeah, Siddharth, so I would like to just show here the end mill range from Dharma Pramet what we have right now. Dhruv, can you go to the next slide? Yeah, so you can see the on your screen you can see the variety of end mills what we have in our basket. So we have end mills dedicated for all for workpiece material. For example, we have the S2 series dedicated for super alloys. We have the S6 series dedicated for uh, uh, aluminium. Then we have this S5 series dedicated for hard materials. We have the S7 series dedicated for steel, stainless steel, and cast iron. S8 series again dedicated for stainless steel and steel. And then we have this S9 series, which is the general purpose end mills, which you can go for means like smaller depth of cuts, or maybe where you need to balance both in between the cost and the productivity. That also we have. So you can see at the bottom the dynamic milling end mills what we had discussed in our very first session, the
Ah,
S7 series, which again comes with the 5 flute design and the differential pitch design with the chip splitter design, through coolant feature. All these features are available with these kind of end mills.
absolutely, absolutely. I hope with this we can close this sessions for a question and answer, and I hope we could able to deliver what multitasking machines, what are the kinematics of the multitasking machine, what is the requirement of multitasking machines, and how efficiently you can use the tools, how efficiently you can use the strategies. I hope audience must have gathered some kind of informations, and if you have any questions or anything, please feel free. Over to Priyanka.
Thank you, Sandeep and Sitanshu, for that commanding, insightful, and exceptionally detailed walkthrough. Your expertise showcased exactly how tools and CAM software can operate as one unified powerhouse. Now, it's time. We now open the floor to your questions. If you haven't shared them yet, this is the perfect moment. Drop your queries into Q&A panel and let's unpack whatever's on your mind. Over to Dhruv.
Thank you, Priyanka. Good afternoon, everyone. If you have any questions, please feel free to write in the Q&A box. All right, we have a first question. Uh, this is for Sitanshu sir. How does the sync manager handle conditional weights, cross weight codes, and spindle dominance?
Okay. Synchronization manager provides a structured way of coordinating operation between the upper lower turret and the spindle as well as the B axis. There is a many codes that you can weight codes you can use it, but that conditional weight codes and cross weight codes and the spindle weight codes and the visual timeline. So depending upon the requirements, the user can define those codes within the software strategies. So it will implement and all synchronization done through the software. So there is so differences of collision will be avoided automatically and software will suggest the weight codes accordingly.
Thank you, sir. We have another question. Uh, what is the recommended insert geometry for high-speed interpolation milling on multitaskers? Sandeep sir, would you like to answer it?
Yeah, so recommended geometry again, like when we are talking about the geometry, so it is very important to understand your workpiece material group as well. So because for different workpiece material group, there could be a different geometry. For example, when we talk about your workpiece material like stainless steel or super alloys or aluminum, where we have the issue of the built-up edge. So you cannot go with a very stronger geometry. So there you should be using a sharp geometries. At the same time, if you have the geometries, like if you have a machining like steel or maybe the cast iron, then maybe you can go for a medium geometry. Or again, depending on like if you want to really go for a even aggressive cutting parameters, you can go for a roughing geometry. So it is a combination. You need to understand that what kind of setup you have, what kind of workpiece material you have, and defining all those, understanding all those all those parameters, then you can select right geometry for the tools. So it is very important, as I mentioned. So it is not very easy to select right cutting tool geometry. But in general, if you say, so there are multiple geometries: roughing, medium, and the finish geometry. So depending on your setups, depending on your maybe requirement, if you need a finishing application, you can go for a finish geometry. If you have a medium operation, you can go for a medium geometry. And if you are roughing strategy, roughing operation, then you can go for a roughing geometry. But again, as I said, so workpiece material also comes into the picture for a right selection of geometry.
Great. Sir, we have another question for you. Which cutting tool
Okay.
feature is most critical for milling operations in multitasking machines?
Yeah, I think this is really a very exciting question and really a very good question to understand this. Like what kind of critical parameters when we are doing this milling operations in multitasking machining. So, one major important thing is like the runout accuracy of your tool. So one thing is the spindle runout, and the second thing is the 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 runout of your tool itself, maybe the axial and the radial runout of your tool. Maybe for example, when we talk about suppose that a milling cutter. So when we are giving a milling cutter, talking about the milling cutter, so there will be an inbuilt runout of the tool, like the pocket accuracies. I'm talking about the pocket accuracies and the insert accuracy. If it is not well balanced, so you will face the issue of vibrations. You will face the issue of chattering. So one thing is the runout, and the second thing, maybe the critical parameter. If you say the overhang of the tool, you should be. We mentioned already. So we should be keeping the overhang of the tool very optimum. It should not be more. We should be keeping the whatever as per the requirement of the application. And here I think the with the help of Mastercam, you can see the simulation in well advance so that you will avoid the collision. Uh, and again, the third thing that it should be having the through coolant feature as well. Because if you are not having this through coolant feature, then you can end up with the chips accumulation at the bottom, or maybe the chips accumulation at the component side. I hope this answers the your questions.
Certainly. Sitanju sir, we have a question
Yes.
for you. What about post-processor customization for complex Milton machines? And is it possible to do this in Mastercam?
Yes, absolutely. Because as I told before, maybe some other webinar, the post processor is plays an important role, and it has to be always customized at the as per the customer need. Every machines has been sold in USA, Japan, or India are different. It may be a same series, same controller, but some internal options are not available on different countries wise, locations wise. So we could able to customize each and every post processor available at customer machines available at customer end, or our engineer locally visit them, understand the machines, and we can able to customize it.
Great. And following up to this question, why machine simulation is needed?
Yeah, this is a good one. Says, for example, machine simulation, why we need it? Because to understand, first of all, we always require the accurate model, which is the accurate CAD model required from the machine simulations. The important thing is toolpath sequencing and synchronizations. So uh, it should create such kind of a toolpath which will not collide. All movements and everything will be happen in the safe zone. Rather very nearer to it has to change. So all movements and everything always happen into the safe zones. So by understanding the limits, kinematics, accessories, parts, fixtures, this help definitely help to avoid all those collisions and make a user more confident to run the program out from the software and directly run on the machines.
Great. And we have a question where I can download models for our reference for
We are
today's
here.
seminar.
We are here. Please contact us. We'll give you as per the module, machines, everything will be supplied by us only.
Great. I will take the last question as we are running out of time. The question is, what are the benefits of having a common interface for using milling and turning strategies versus that of having them in a separate interface?
Yeah, as we discussed many slides regarding this multitasking, because when you go for a separate operation, separate machines, accuracy, dimensional accuracy, finishing, everything comes into the picture. We will not able, also the timing. The same part can be machined very quickly on the multitasking machine where you can spend 4 or 5 times higher in the normal machines, like if you individually machines all those parts. So definitely this multitasking machine is a game changer for today's world.
Great. Thank you so much, Sitanshu sir and Sandeep sir, for sharing your insights. Over
Thank you
to you,
so much.
Priyanka.
Thank you. Thank
Thank
you.
you, Dhruv. Thank you for your thought-provoking
Thank you,
questions and your
participant.
energetic participation. It's what elevates this session. Now, uh, if your questions wasn't covered or you need deeper insights, please simply scan the Contact Us QR code on your screen to explore more tooling innovations and software capabilities. Scan Find More or QR code. I'm keeping the screen for like 1 minute so that you guys can scan the QR code and get in touch with us. So please scan this QR code. Okay. And yes, the complete session recordings and materials will reach to your inbox shortly. Thank you for being a part of session 3, conquering multitasking, machining, productivity in one setup. Your enthusiasm, your drive, and your pursuit of excellence are what fuel this industry's progress. We look forward to seeing you in next chapter of Machining Harmony series. Stay sharp, stay innovative, and keep machining in perfect harmony. Thank you. Until then, bye.